Let's discuss that workaround and see the actual results. Let me close this application. Let me bring up the network data manager GUI and open the network from here. You can see here from the picture we are actually passing two inputs, and the two inputs we are applying a weight plus some bias function, summation function, and a transformation function. So the layer output, one's output can be written as y is equal to, or y1 is equal to tensing function of weight, layer 1 weight multiplied by the input plus a bias. And the same thing actually can be applied here also, with instead of input we have to use the layer 1's output. So say y2 is equal to, or result is equal to the tensing function of LW. Here in this case it's represented as LW in the network structure, NN structure. So LW multiplied by the layer 1 output plus bias 2, which is here, you can see, and the tensing function, apply the tensing function on that. So we are actually writing a simulating a sim function. Basically sim function does the same thing for us behind the scenes, since sim function is not supported by the Matlab compiler. So our deploy tool, we have to use the this approach, where we actually split the neural network in terms of the number of layers, and use the tensing function on each of these, transformation function on each of these layer. So let me change, first let me close this and let me change the our M code. So I have wrote already something like this. So you can see here y1 is the layer 1 output, and I am applying a tensing function, and the XOR net IW 1 gives me the layer 1 weights multiplied by the input plus XOR net dot bias 1 gives me the first layer bias. So adding this and applying a tensing function, we will get the layer 1 output, and then applying the layer 1 output here, and the weights of layer 2 multiply plus bias of layer 2, and applying a tensing function here. So we get the results. So we actually simulated the sim function. Now let me convert this using the deploy tool. Let me build this application once again. Now the compilation is completed. Now we have a new assembly which contains the changes related to the my XOR net, which uses the tensing function or removes the sim function dependency with our M code. Now let me open my project, Microsoft Visual Studio project, C# application. Let me build solution once again. Let's clean and rebuild. Now clean and rebuild. Start the application again. So we have got sim. Now you can see the result here, which is same as the Matlab result we have tried. 0 0. You can see here result. Let me arrange these windows so you can see the same result. So we actually got around with the problem with the sim function, and we actually simulated the sim function itself. Now let's try with some other input. 0 1. Now this time 0 1 with 0 1. Let me click on sim button. Okay, we got the answer 1. Now please note that when we recompiled or rebuilt our modified version, so we have to rebuild our C# financial project so that it picks up the latest assembly from the location uh, where it refers. Basically that location is under this distrib folder, so you have to clean and rebuild the project in order to pick up the latest assembly. I hope this screencast gives some idea about the neural network toolbox, as well as how we can use the neural network toolbox in C# application, and waiting for your feedback. Thank you very much. Hope you do. See you soon. Bye.